In 2016, a 12-year-old boy in Siberia was killed by anthrax. The bacterium that got him had been frozen in the ground for 75 years, locked inside a reindeer carcass buried under permafrost. A heat wave thawed it out, the spores activated, and the kid died from something everyone assumed was long gone. The things buried underground aren't dead, they're dormant, and some of them were already resistant to our best drugs before we ever invented them. This video is about a bacterium that survived for 250 million years, a cave sealed since before humans existed, viruses the size of bacteria thawing out of frozen tundra, and the possibility that extinct animals, mammoths, giant sloths, Neanderthals might hold the cure to infections we can't treat anymore. Let's get into it. Number 1. They're already resistant to our drugs. There's a cave in New Mexico called Lechuguilla. You can't walk into it. You can't stumble across it on a hike. It sits beneath hundreds of feet of impermeable rock, sealed off from the surface world by geology so dense that rainwater falling above it today won't reach the deep sections for another 10,000 years. No human touched it until 1986. No surface bacterium has made contact in over 4 million years. The air down there smells like wet stone and nothing else. It is as close to a sterile alien world as you will find on this planet. And yet, scientists pulled 93 bacterial strains off the cave walls, about 1,000 feet underground, growing in thin biofilms on rock faces in total darkness. Roughly 70% of them could resist 3 or 4 classes of antibiotics. 3 of the strains shrugged off 14 out of 26 antibiotics thrown at them. These are drugs that didn't exist when these bacteria last saw daylight. These are drugs that didn't exist when our species last saw daylight, and the bacteria were already immune. But the real star was a bacterium called Penibacillus LC 231, resistant to 18 antibiotics, including daptomycin, which is one of the last drugs doctors reach for when everything else has failed, when the infection is winning and the options are almost gone. This single organism, living on a rock wall in permanent darkness, 1,000 feet underground, had 5 resistance mechanisms that had never been documented in any living thing, anywhere on Earth. Now here's the part that should genuinely unsettle you. Relatives of this bacterium live on the surface, in soil, in hospitals, in the world you walk through every day. And when scientists compared their resistance strategies to the cave strains, they were functionally identical. 4 million years of complete separation, 0 contact, no shared environment, no shared selective pressure, no possible way to exchange genetic information, and the same defensive playbook, move for move. That means antibiotic resistance isn't something bacteria learned from us. It's not a reaction to factory farming or overprescribed amoxicillin or hand sanitizer in every waiting room. It's the factory setting. Bacteria have been waging chemical warfare against each other for longer than complex life has existed, and resistance was already baked into their DNA before anything with a spine ever crawled out of the ocean. We didn't create the problem. We walked into a war that started billions of years before us and assumed we were the first ones to show up with weapons. One detail, though, that cuts the other direction. These cave bacteria, they were sensitive to purely synthetic antibiotics, drugs with no natural equivalent, molecules that don't exist anywhere in nature. They can only resist what nature has thrown at them. Anything truly alien to their experience still works, which means the arms race isn't hopeless. But you need to understand what you're racing against. And it isn't modern, it's geological. Number 2, they can wake up. In 1995, a team drilled into a salt crystal 1,850 feet underground near Carlsbad, New Mexico. The site was a nuclear waste repository, one of the most geologically stable, carefully studied formations in the country. Inside the crystal was a microscopic bubble of brine, ancient seawater, sealed shut when the salt formed. Inside the brine was a single bacterium. They placed it in a nutrient solution. It grew. The salt deposit was 250 million years old. That's the Permian period. Let that land for a second. The worst mass extinction in Earth's history was happening at the time this thing got trapped. Dinosaurs wouldn't exist for another 20 million years. This bacterium predates the entire age of dinosaurs. It predates their extinction. It predates the rise of mammals, the evolution of grass, the splitting of continents into the shapes you'd recognize on a map. It predates every single second of human history by a margin so wide that human history doesn't even register as a rounding error. If you compressed all of Earth's existence into one calendar year, this bacterium went dormant around October 8th. Humans show up at 11:36 p.m. on December 31st. You are less than a half hour old. This thing has been asleep since fall. How does anything survive that long? Endospores. Some bacteria can sense when conditions are about to kill them and respond by wrapping their DNA in a protein shell so tough it resists heat, radiation, desiccation, and chemical attack. It's not alive in any meaningful sense. It's not metabolizing. It's not reproducing. But it's not dead either. It's suspended. A biological pause button pressed down for geological time, waiting for something to change. Other bacteria use different tricks. Some lock themselves into stable matrices like salt crystals or amber. Some shift their cell membranes into rigid configurations using specialized fatty acids, essentially freezing in place without ice, holding structure through sheer chemistry. Now, honesty check. The 250 million year claim is real, it was published, and it has never been definitively disproven, but it's actively debated. Critics argue that DNA simply can't survive that long, even inside a spore, because background radiation would shred it over those timescales. The original team published detailed rebuttals, and the argument hasn't been settled. If it's genuine, it's one of the most staggering things biology has ever produced. If it's not, even the conservative estimates of bacterial dormancy, tens of thousands, hundreds of thousands of years, are long enough to change how you think about what's alive beneath your feet. Because the next section isn't about what scientists carefully drilled for in a lab. It's about what's thawing out on its own. Number 3, they're being released right now. Summer 2016, the Yamal Peninsula, deep inside the Arctic Circle, temperatures hit 35 degrees Celsius, 95 Fahrenheit, in a place that's supposed to be frozen year-round. The permafrost softened. Layers of earth that hadn't been liquid in decades turned to mud, and somewhere beneath the surface, a reindeer carcass from a decades-old anthrax outbreak began to thaw. The flesh loosened. The spores inside, locked in suspended animation since the original outbreak, met warmth and moisture for the first time in 75 years. They woke up. 2,649 reindeer died across the peninsula. 36 people got sick. Nomadic Nenets herding families, people who'd lived on that tundra for generations, were airlifted out by military helicopters. Troops in hazmat suits burned infected carcasses across miles of open ground. The air smelled like char and rot. A 12-year-old boy, the one from the beginning of this video, didn't make it. There are roughly 7,000 known infected livestock burial sites scattered across northern Russia. Most of them are shallow. Most of them are mapped poorly or not at all, and the permafrost holding them shut is warming faster than almost any other surface on Earth. This isn't surface frost you scrape off a windshield. Siberian permafrost extends over 1,000 feet deep in places, roughly the height of the Empire State Building. It's a deep-time freezer, and it's been sealed for tens of thousands of years, in some regions hundreds of thousands. Every meter that falls is a new layer of biological history exposed to the open air for the first time since before your species existed. And it's not just bacteria coming out. In 2014, researchers thawed a virus from 30,000-year-old permafrost in Chukotka, northeastern Siberia. They called it Pythovirus sibericum. It was infectious on contact, 1.5 micrometers long, visible under a standard light microscope, which viruses are not supposed to be, 10 times the size of HIV, shaped like an ancient Greek amphora, carrying 500 genes. HIV has 12. Genetically, this thing is closer to bacteria than to anything we normally call a virus. It's not a virus in the way you picture a virus. It's something else, something older. The year after, they found another one, Mollivirus sibericum, also infectious upon thawing. also 30,000 years old. Also not something that fits neatly into existing categories. By 2023, 13 more ancient megaviruses had been pulled from permafrost across Siberia, the oldest dated to 48,500 years. Now, none of these infect humans, they target amoebae, and some virologists have pushed back hard on the panic. One prominent researcher argued in Nature that the idea of melting ice unleashing dangerous human pathogens stretches scientific rationality. We already inhale thousands of viruses every single day. The 2016 anthrax outbreak may have been made worse by a lapsed reindeer vaccination program. Not just the four itself, fair points, all of them. But here's what keeps the researchers up at night. The risk isn't one super pathogen crawling out of the ice like a horror movie. It's math. Trillions of ancient microbes released simultaneously across thousands of miles of foreign ground into ecosystems that have never encountered them. Even if only a tiny fraction of a percent can infect anything relevant, that tiny fraction applied across trillions of events is not a small number. It's not about the single monster, it's about the volume. And we're not choosing to open this freezer, it's opening itself. Number 4. They've already shaped the world more than anything else alive. You've been hearing about bacteria as a threat, something hiding, something waking up, something we might need to fight. But bacteria have already done the single most destructive thing any living organism has ever done on this planet, and it happened 2.4 billion years ago. Cyanobacteria figured out photosynthesis, a neat trick. Eat sunlight, spit out oxygen as waste, except oxygen was poison. Every dominant life form on the planet at that time was anaerobic. They ran on chemistry that oxygen destroys, and cyanobacteria just kept pumping it out, generation after generation, century after century, for millions of years, with no awareness and no intention, until the atmosphere flipped entirely. The biosphere shrank by over 80%. Some estimates push it to 99% of all life wiped out. Not by an asteroid, not by a volcanic eruption, by a waste product, by bacterial exhaust. The oxygen also ripped apart atmospheric methane, which had been keeping the planet warm, and triggered a glaciation so severe the entire Earth may have frozen over. Poles to equator, ice everywhere, a white marble hanging in space, one type of organism, one metabolic byproduct, and it rewrote the atmosphere, the climate, the chemistry of the oceans, and the trajectory of every living thing that would ever follow. You're breathing oxygen right now because of a bacterial apocalypse that almost sterilized the planet. Every animal, every plant, every complex cell on Earth exists in the aftermath of what bacteria did when they weren't even trying. They aren't passengers on this planet. They've been driving it since before the road existed. Number 5, they might also save us. Here's where the story turns. In a Romanian ice cave, sealed and cold and dripping in the dark, scientists pulled out a 5,000-year-old bacterium called Cycrobacter SC65.3. Resistant to 10 modern antibiotics across 10 different drug classes, a broadband survivor. It carries over 100 resistance genes, which is terrifying, but it also carries 11 genes with the potential to kill bacteria, fungi, and viruses, and nearly 600 more genes whose functions are completely unknown. Nobody knows what they do. Nobody's ever seen them turned on. It's a weapon and a pharmacy frozen in the same organism, and we've barely opened the first drawer. And that's just one microbe from one cave. A lab in Pennsylvania is doing something that sounds like science fiction, but is happening right now. They're using artificial intelligence to mine the genomes of 208 extinct organisms: mammoths, mastodons, giant ground sloths, Neanderthals, ancient elephants, hunting for antimicrobial peptides, small molecules that kill bacteria. The kind of thing we desperately need because the antibiotics we've relied on for 80 years are failing, one by one, against superbugs that evolved resistance before we ever made the drugs. They found over 11,000 candidates that nobody had ever seen before. 11,000 potential weapons buried in the DNA of animals that have been dead for thousands of years. They synthesized 69 of the most promising ones and tested them. 2 worked well. One came from an ancient elephant. One came from a giant ground sloth that went extinct roughly 12,000 years ago. Both performed comparably to a leading modern antibiotic in mouse models. They even pulled a peptide from encrypted sequences in Neanderthal DNA and named it Neanderthalin-1, a drug candidate extracted from our closest extinct relative. Sit with that for a second. We are so thoroughly losing the war against modern superbugs that scientists are now resurrecting molecules from mammoths and giant sloths and Neanderthals. The deep past, the same deep past that's thawing out and threatening us, might be the only pharmacy we have left. The thing you've been afraid of for 4 sections just became the thing that might rescue us. Number 6. They were here first. Enterococci, the bacteria behind some of the most stubborn, drug-resistant hospital infections on the planet, have been traced back roughly 450 million years, to the moment the first animals dragged themselves from ocean to land. The same genes that helped them survive drying out on prehistoric shorelines, baking in open air for the first time, now help them survive the alcohol wipes and antiseptic scrubs in your nearest ICU. Same genes, same trick. 450 million years apart. In early 2026, researchers reported viable bacteria recovered from 2-million-year-old permafrost, carrying resistance to at least 10 modern antibiotics. 2 million years. That pushes the known timeline of resistance back by orders of magnitude. Not thousands of years, not hundreds of thousands, but millions. Bacteria have been waging chemical warfare against each other for billions of years. Our antibiotics are borrowed weapons from that war. Most of them are derived from compounds bacteria and fungi already invented, already deployed, already built defenses against. Resistance wasn't a response to us. It was already in the library before we ever walked through the door. You clicked on this video because the title asked why prehistoric bacteria are more terrifying than modern ones. And the answer is that the distinction doesn't exist. The modern ones are prehistoric. They carry ancient genes, ancient defenses, ancient strategies refined over timescales so vast that human civilization isn't even a footnote. The scary ones in hospitals right now are running software that was debugged before the dinosaurs. Bacteria were here billions of years before us. They caused the first mass extinction. They carry weapons older than bones. They're waking up from permafrost as you watch this. And the same ancient world that's threatening us might be the only place left to find a cure. They were here first. They'll be here last.